Good afternoon and good morning to those of you out west. Welcome to today's webinar from Metal Architecture Magazine and AEP Span. My name is Stacy Ranella. I'm the editor-in-chief for Metal Architecture, and I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started, if you have any questions during today's webinar, please enter them using the Q&A section, which you can find at the bottom of your Zoom window. We will address as many questions as possible during and at the end of the presentation. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, only use the Q&A instead. If you're experiencing any technical difficulties during the webinar, you can either enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's webinar is being recorded and will be available on Metal Architecture's website by this time next week. Now I'd like to introduce our speaker, Jeffrey Medeiros. Jeff is the architectural representative for AEP Span and is a licensed contractor who has been supporting architects in California for close to 20 years. He can spec write, assist in detailed drawing, and aid in product selection or any aspect of the design build process from initial design to complete bid-ready documents. He is fluent in building code, bid laws, and contract code. Jeffrey provides architects with the full range of service from conception through bid. He holds various degrees, including Law and Society from UC Santa Barbara, Japanese from Waseda University in Tokyo, Japan, and he attended McGeorge School of Law in Sacramento, California. He is fluent in all types of roofing systems. In this webinar, Jeffrey will discuss metal roof systems, design, and installation considerations. Jeffrey, we appreciate you joining us today. Please take it away.
All right, unmuted. Can everyone hear me? Yeah, we're good? Okay. So, welcome. Everyone have their cup of coffee and or water or lunch. Let's get started. I'm going to turn off my screen in interest of the video so we can make sure this keeps rolling. I will turn it back on to answer any questions during the presentation. Okay, metal roof design and installation considerations. This is the required slide that I show for AIA credit, course number, learning units. So let's get started. So here's one of the two slides I will be reading. At the end of this program, participants will be able to list the advantages and disadvantages of architectural roofing versus industrial roofing, as well as the features of exposed fastener versus standing seam assemblies. State the specification considerations related to metal roof installation, discuss energy efficient features of metal roofing and environmental impact, and design issues that help facilitate a successful roof installation. All right, now that that's read, let's get going. This course is going to start with a discussion of the pros and cons of architectural roofing versus industrial roofing, followed by an overview of exposed fastener versus standing seam, concealed fastener, spec considerations, and so on. So let's start with the type of roofing systems. Okay, there are two types that I want you to pay attention to: architectural and industrial. An architectural roof system is specified for performance, life cycle costs, and primarily aesthetic reasons. The roof is often part of the overall aesthetic design. Non-structural metal roofing usually requires a solid substrate beneath it, such as plywood, a roof metal deck, or rigid insulation over a substrate. However, there's also spannable architectural roof systems that can span open purlin. An industrial roof system, on the other hand, is selected for function, performance, and when cost is the major factor of a project, feasibility, so on. Structural metal roofing attaches directly to the secondary and structural members and may not require any sort of solid support beneath it. So this slide, we're going to skip by because I'm going to talk about exposed fastener. So I want you to think of exposed fastener when you think of industrial, okay? Exposed fastener by definition is through fastened. Visible fasteners, exposed fasteners, right? Nestable. You can stack them alternating back and forth. So if you have a sine wave type of roof, you can stack one valley to the right and then stack one to the left. So they can ship on a pallet. Pretty cool. They rely on laps and sealant for waterproofing. Okay. Exposed fastener, nestable, laps and sealant, and through fastened by design. I don't care what kind of profile it has. I don't care if it has a sine wave, a trapezoidal, a box. I don't care. Corrugation is repetitive. Again, nestable, laps and sealant, through fasten. This is considered the standard in the metal building industry for well over 50 years, actually going on 75 to 100 at this point. Exposed fastener roofing systems, right? Pop quiz, they're known as through fasten systems. They provide a very economical performance value option. They're durable, lightweight, whatever finish you want to run with. The panels can be installed on a roof or on a wall, vertically, horizontally, whatever. Many of the exposed fastener configurations can be fabricated in varying gauges and can provide both negative and positive load carrying capacities. Please note that some exposed fastener panels have been tested to provide diaphragm support. So an exposed fastener panel, again, relies on visible fastening. So as you can see in this photo below, or this depiction below, there are fasteners that go through the peaks and into the substrate to fasten the panel, hence through fastened. They are lapped, as you can see right here. One panel laps over the other to provide waterproofing. So this is what we're talking about when we talk about industrial panels. Corrugated, through fastened, all the same. The one thing that I do want to point out is every single one of these panels is pinned at every attachment point. Thus, it doesn't allow for thermal movement. So over time, the expansion and contraction of these panels may create a elongated hole at the screw location. And what I want you to think of here is I want you to think of nails in a fence, okay? You're going to walk by your fence one day and you're like, hey, these nails are backing out. What's going on? Or these nails are loose in the board. That's because the nails thermally cycle. Metal thermally cycles, gets hot, gets cold, right? So these roofs want to move, but they're pinned. They want to dance, they want to party, they want to have a good time, and they can't move. They're pinned. So corrugation acts as a little spring. And what I mean by that is every single repetitive profile that you see acts as a little spring to absorb that thermal movement. However, they are still limited. So they may, over time, expand and contract, and a little hole grows. So typically, exposed fastener panels are used on shorter panel runs, and they're not recommended for slopes less than 1 in 12 over a conditioned space. Actually, it's defined under code that they are not acceptable for a conditioned space over 1 in 12 with laps and sealant, and it's 3 in 12 without laps and sealant. So in these cases, a standing seam metal roof is preferred, right? Okay, standing seam. Everything's the opposite of exposed fastener. They do not have exposed fasteners. They're concealed, which is why standing seam is concealed by definition. They are not nestable. You cannot stack a 12-inch or a 16-inch wide panel inside of another 12-inch or 16-inch wide panel. I know what you're thinking. You're correct, unless you flip it upside down and alternate legs, right? But you cannot nest them like you can with exposed fastener. So very different. They are selected typically for a much higher waterproofing ability and ease of installation. Not as easy as an exposed fastener panel. I mean, let's be honest. We can get out there, you, me, and a couple of buddies with a case of beer and a pizza, and we can put up exposed fastener panels. Not so with concealed. Not so with concealed. So I'm going to talk about a bearing plate real quick. I believe it's on the next slide. No, I'll talk about it right here. Okay, so I'm going off this slide just for 1 minute. Rigid insulation isn't so rigid, right? It has a compressive strength of around 25 psi. So a compressive strength of around 25 psi means if you walk on it, we're putting footprints in that sucker, okay? if we walk on it, we will leave footprints. So if you fasten a concealed clip through rigid insulation with no bearing plate, the clip will sink into the rigid that, again, quote unquote, ain't so rigid, right? It'll sink into that rigid and the fasteners are going to lose tension. Well, not good. A bearing plate acts as a snowshoe. It's a pre-punched plate. You can slide this clip into. It acts as a snowshoe to distribute the weight of the clip or the pressure of the clip under tension. Then it won't sink into your rigid. Moving on. Couple different types of standing seam. This one right here is a male-female interlocking panel. Male leg entraps the male leg. There's sealants right here in the female leg. Click and lock, snap lock, done deal. Mechanically seamed. Male panel fits inside the female panel. There's also some of these panels that are non-directional. There's T-seams and bulb seam panels that are non-directional. You seam them with a mechanical seamer. They can be seamed 90 degrees, as shown here, or 180, as shown here. This is simply this panel rolled over a second time. What's the difference, you ask? The reveal of the clip, of the standing seam leg. Right here, it's 1.5 inches. Right here, it's 1/2 inch. There are old school type batten seams, okay? These are the same, but I want to draw your attention to this one right here because it shows better what it looks like, all right? If you were to blow up this gap in between this 90 and this 90, there's a gap there. Let's pretend that this is it. This is a gap that's left exposed. They're batten style panels because the panels are 90s that engage a clip that have tabs that fold over, and a batten provides the waterproofing protection. If it's a narrow batten like this, the gap's real small. If it's a wide batten, the gap's real wide, and that is to the deck. So with these type of panels, a minimum slope requirement of 3 and 12 is there. All right, so again, standing seam is a panel with no visible or exposed fastening devices for the connection to the substrate. It can provide unlimited thermal movement through the use of a properly designed or thermally responsive clip and fastener. If it's a mechanically seamed, clips are attached to the substrate and entrap the vertical panel legs. Concealed fastener connections eliminate the elongation or fastener penetrations due to thermal movement, common to the exposed fastener systems, as I previously discussed. So they greatly extend the weather tightness of these panels. Let's talk about clips. One-piece clips. These are commonly used on male-female snap lock systems and or T and bulb seam standing seams that allow for unlimited thermal movement. The panel slides over this clip this way, downslope towards the eave for unlimited thermal movement. The two-piece clips are typically for mechanically seamed panels, and these give a movement from this point to this point, which is typically plus or minus 1 inch. So you want to center that clip, right? And the panel can expand or contract plus or minus 1 inch within this clip. This clip is seamed into the panel leg. So it allows the panel to float back and forth under thermal cycling along the base of the clip. Okay, bearing plates. See, I knew there was a slide. I got ahead of myself. Bearing plates, again, this is what a bearing plate looks like. It has pre-punched holes that the clip slides into, and it acts as a snowshoe to distribute the weight or the pressure of that clip under tension of the fasteners over quote unquote rigid insulation, because rigid isn't that rigid, right? Okay. Standing seam panels can be used for long runs, low slope installations, but it is very important to be aware of the limitations. Continuous standing seam panels in extra long lengths can perform, I should say, not use absolutes, can perform differently than installed lapped panels. However, extra long panels are prone to installation damage and present much greater installation challenges. So, for example, let's say you're going to design this roof right here. It's 150-foot long panels. Okay, so you want lapless panels. Great. 150 foot. You cannot transport them to site. That means you have to roll form them on site, which means you have to pay significantly more to get the coil to site, pay for an on-site roll former to be there, a manufacturer's representative to be there, and then you roll form those panels on site with 150 foot run out that has to be available on site. You then have one person per 10 foot stick try to transport this panel to a staging area where you have to secure it to a crane with a spreader bar that you are paying for the rental for, attach it, have perfect wind conditions, and then lift it onto the roof, again, potentially one panel at a time. And if the contractor makes any mistakes, God forbid, or catches something, or a gust of wind hits it, you are out a 150 foot long panel. So what's easier to do? One 150 foot long panel or three 50 foot long panels that you can lap that are manufactured at a plant and transported to site on a truck. You also eliminate the one person per 10 foot stick requirement, your crane, your spreader bar, your site access, your control, and so on. I'm not saying you can't do long length panels. Just be very aware of the positives and negatives to each one. So if continuous length panels are required, ensure you deal with a quality supplier, because not all portable roll formers are equal. Many of which I've seen out there are operated by not UL certified panels that are piggybacking on testing from a manufacturer that's in different states, and there's no chain there for you to hold someone liable. It's someone that bought essentially a gutter machine, right? And they're out there rolling. This is very common in rural areas or areas that are hard to get to, like Alaska and so on, right? Make sure you ask for a UL certified roll former that is direct from the manufacturer you are purchasing from. Period. Don't screw around. If you want to go forward with the long length panels and you want to deal with everything else, this is the starting point. So available in this market are non-structural and metal roofing panels designed to shed water over solid substrates, as well as those that can be used over open purlin and open framing conditions. So with limitations based on wind uplift and condensation control, meaning the roofing can be installed over wood substrates, such as solid wood decking or plywood, nail base, insulation, SIPS panels, etc. Metal roofing can also be installed over steel substrates, including structural steel decking, light gauge, structural secondary framing components, new construction, retrofits, and in some cases with bearing plates, again, directly over selected types of rigid insulation and so on. And cover boards that you can act as a non-combustible, so you can get a Class A fire rating in assembly designs. That was a lot there, so if we want to go over it later, let me know. Speaking of substrate, everyone thinks substrate doesn't matter. Metal will not follow substrate. Nope, it will. It will follow the substrate, 100%. So make sure your substrate is true before you roof over it. A poor substrate can result in severe oil canning and lead to premature failure, as well as any inconsistencies will be revealed through that metal panel. All right, underlayment. Underlayment will depend on several factors, from condensation control, snow density, rainfall, heat developed, building type, so on. I don't want to go down this rabbit hole because we could spend an entire discussion on this. If you have questions on what underlayment should be used, reach out to me after. It's going to vary on location. If you're by the ocean, if you're on the water, if you're in snow, if you're an indoor pool, if you're a museum, it has to have a climate controlled, moisture free environment, so you're not going to damage, Michelangelo's paintings and so on, right? There's a lot that goes into this. So reach out to me on this. But the one thing that I do want to focus on is, I'm going to skip past this real quick. Nope, hang on. It's not there. That slide's gone. Okay. A metal underlayment should be high temperature. Okay. it should be a high temperature peel and stick underlayment. And what I mean by this is it has happened, and I have a picture I'm going to show at the end. A 30-pound felt or an asphalt impregnated felt can reemulsify under hot temperatures and run down the sides of your building. So be aware and use a high temperature metal underlayment, preferably peel and stick, like an ice and water shield. Vapor retarders can act as air. I don't want to go down this rabbit hole. Again, it's very dependent on building type. So reach out to me if you have any questions or concerns with your specific building. So exposed fastener panels. I want to talk about gauge real quick. Exposed fastener roof panels, because they're used on industrial buildings quite often, metal buildings, they're typically lighter gauge, right? They're 26, 28, and so on. I don't like that necessarily. I like 26, 24, and 22. 24 and 22 are industry standard. 26 is industry standard for metal building. And then you can go lighter. 20 and 18 gauge are available for added durability and so on, or when you need diaphragm or greater positive load carrying capacities. That's exposed fastener, right? Think silos and metal buildings, right? You can put them up real quick. Standing seams typically do not come in 28 and 26 gauge. They come in 24 and 22 and 20. 24 is considered industry standard. 22 is what I like to use in areas of long panel runs or snow country and so on. Although test data is sometimes limited, both exposed fastened panels and standing seam panels can be often provided in a variety of metals as well, like aluminum, copper, stainless steel, to meet different environmental or specific design considerations. So be aware of those gauges. Industrial exposed is typically lighter. Standing seams typically 22 or 24. However, I like to keep it solid at 24 for the majority of things, unless you have a very impactful condition, i.e. snow or long panel runs, which you go to 22. So questions. I'm going to put my video back on so everyone can see. Questions at this time?
We have a couple questions for you, Jeff.
All right.
Is it possible to unseam damaged standing seam panels in the middle of the field for repair?
Okay, that's a super good question. Whoever asked that, kudos to you. Yes and no. It depends on your panel type. If you have a male-female panel leg, where the male leg is entrapped by the female leg, it's directional, right? You have to install from the left and you move to the right because the panel, it's entrapped as you move over. If that happens, you are up a creek without a paddle. You need to take off everything to the side of that damaged panel and reinstall. However, if you have a non-directional panel, i.e. a T-seam or a bulb seam where the panels come together and go up and there's a batten, you can cut the batten open, pull those two panels, and then reinstall. So my answer is yes and no, depends on what type of panel you're using. Generally speaking, batten type panels you can, whereas male-female directional panels or directional mechanically seamed panels, you cannot.
Okay, thanks for that. What is the preferred detail on standing seam hip caps to avoid oil canning?
I'm going to ask that you email me that so I can send you a response via email because it's going to be difficult to.
Okay, we've got one more question here.
No problem.
Can oil canning be completely avoided?
Man, that's the $100 question. Okay, so I'm going to take a second and answer this, and this is very important, I think, to get this right. Oil canning. Okay, so there's two different types of oil canning, right? There is, we go out to look at this project, and we're standing side by side, and we look at this, and we go, man, that doesn't look straight. It looks oil canned. Well, that's popular nomenclature, right? That's our oil canning that we see. We don't like the way that it looks. However, true oil canning is defined in SMACNA is a repeatable, measurable part of the roll forming process. So what that means is it looks like a bump or a divot or a dip. And you can throw a tape on this and you can measure every 12, 16 inches. And something's off in the roll forming process. So that is a manufacturer's issue. However, I walk out to a building, a structure, and I go, I don't like the way that wall looks. It's not singing right. There are so many things that go into potential for oil canning. Panel width, panel profile, temperature of the metal. Is it heating and cooling quickly? Was it mishandled? Is it pinned? Is there a pop rivet someplace on a piece of trim and flashing that's not letting it move? Can it thermal cycle? Is it a white panel or is it a darker color panel? All these things. Was it packaged incorrectly? Did it get damaged in transit? So my answer is every single manufacturer out there will put something to the effect of oil canning is an inherent part of the metal manufacturing process, and it is not a cause or reason for rejection. However, there are ways to minimize that. And I'm talking about that I'm looking at something that looks oil canned. Profiles. You don't want flat. Flat tends to be more wavy. And what I mean by that is if you take a piece of paper and you crease it in half, and then you push it together on like a granite table or a desk, it'll flex at that same point, that fold, every single time, no matter where you put your fingers. If you take a flat piece of paper and you change where you put your fingers, it'll flex differently every time. So that's what a profile does. A repetition in corrugation does the same thing. It's a predefined point of flexation. Gauge is a major issue. Is it 26 gauge or is it 22? Is it 20? Color, all that. So there are ways to mitigate or minimize it, but to get rid of it completely, man, that is the golden apple that we are all after. There is no way to do that, but there are ways to help. And if you want some assistance with this, reach out to me and I can go through this process with you. That was a long answer. I'm going to move on.
Yeah, let's continue with the presentation, Jeff, and then we'll get back to more questions after that.
Can do. Okay, we're going to talk about coatings real quick. Aluminum zinc. It's the most widely used coating for steel. It's 55 aluminum, 45 zinc by weight. Okay, this product is known as Galvalume, Zincalume, same thing. Tissues, Kleenex. Toilet paper, Charmin, right? Galvalume, Zincalume, same thing. This is different than galvanized, okay? Galvanized does not come with a substrate warranty. Once again, galvanized does not come with a substrate warranty. Galvalume, Zincalume does. So if you're looking at different metals out there and you're going to have a submittal come through and it says, oh, galvanized. When you specified Galvalume, Zincalume, night and day difference. So the aluminum component of Galvalume, Zincalume provides that provides the corrosion protection, and the zinc provides that sacrificial characteristic that protects the material edges and cuts. So when used for low slope roofing, Galvalume, Zincalume goes 30 years without corrosion failure, right? Like you can warrant, quote unquote, bare Galvalume, Zincalume for 20 years for crying out loud, right? Again, zinc coated G60, G90, it does provide protection and it does have the self-healing characteristics of zinc, but it's not warrantable. So be aware of that. All right, paint options. I'm going to go off the rails again here because there's some serious industry concerns coming up I'm going to touch base on. So paint options, and this is backwards, polyester, then SMP, then Kynar. So Kynar 500 or Duranar 5000, Duratec, whatever you want to call it, is a PVDF polyvinylidene fluorine, I believe, fluoride. Silicon modified polyester paint coatings are the next step down. They have a 20-year comprehensive warranty and are generally used on lighter gauge products. Both SMPs and polyesters complement the industry with economical paint systems, and they have decreased chalk and fade values. So I'm going to go off the slide for a second here. If you are specifying something and you go, hey, I want my Kynar paint on my roofing or my walls, and then you go, you do not specify flashing and trim, shame on you, right? Because your contractor just got opened up to go buy Regal White from Diamond Supply or ABC Supply or wherever they want to go, and Diamond White that's supplied in the flat sheet for flashing and trim, the 10x4, the 12x4, the 20x4, whatever length sheets you want, that can have a different paint system. SMPs are polyester, not Kynar. You don't get a 30 or 40-year finish warranty with that, right? That's going to chalk and fade and yellow much faster than a Kynar paint system. So specify flat stock for sheet metal flashing and trim shall be sourced from the same manufacturer as the metal roofing in order to, number one, maintain an exact color, and number two, a congruent warranty. Getting back on track now. Okay. So chalk and fade of Kynar 500 greatly outpaces SMPs and polyesters, and it's the most trusted coating and the industry standard in the industry. When it's coupled with the zinc aluminum galvalume substrate, you have exceptional properties, right? Chalk resistance, durability, abrasion, and you have a substrate warranty. So for severe corrosive or saltwater environments, paint manufacturers have developed alternatives to the industry standard 1 mil Kynar. There are warrantable paint coatings over a zinc aluminum galvalume substrate for marine environments. I'll say that again. We can do steel within a marine paint system directly over salt body of water. Warrantable, 20 years. So just because you're over some... Everybody see?
There we go. Yeah, we're good.
Okay. How many did we lose? Oh, we still have almost everyone on. Good job. Okay. Thank you, everybody.
It was a good washroom break. Everyone took a washroom break, and now we're back.
You know what the worst part is I actually reset my laptop several times so this wouldn't happen. So thanks for dealing with me. Okay, moving on. So coatings. Coatings can be put on Kynar, PVDF, SMP. I'm going to turn my other one down. I'm leaving my phone on just in case this happens again so I can switch over immediately. The base steel comes in, and then it is coated with whatever system you want to put on top, i.e. Kynar or so on. So this is how it's broken down. The base substrate, then your primer coat, your Kynar coat. Okay, so when specifying this, I've alluded to this before, is make sure that you specify that sheet metal flashing and trim has the exact same finish as the roof panels, so you don't have a difference in panel color as it fades. There's a couple different types of sealants that can be used. Number one is non-curing butyl. Non-curing butyl is typically tube applied. This type of sealant should be used in any areas of the roof that are subject to dynamic movement of the roof panel, including side laps and laps, flashing attachments, so on. It protects against capillary action, and it allows panels and flashing to react thermally, expand and contract. They can move. It cannot be exposed to the sun. Butyl tape is our next one. Butyl tape is similar to that, but it's available in rolls up to 50 feet in length. Our one that can be exposed to the sun is single component urethanes. They're typically tube applied. They can be colored, and they go on any area that attaches to the metal roof, non-metal surface, masonry blocks, stucco walls, etc. These are typically used outside that interacts with the sun. Okay, moving on to testing and specifying a metal roof system. In interest of time, I'm going to skip over some of this real quick. What I want you to keep in mind here is test data should be maintained and supplied from the manufacturer, specifically ASTM E1592, which is a testament for wind uplift, water infiltration E1680 and 1646. All these should be tested and provided by your manufacturer. Okay, where are we going here? Hang on here. Let me back up. Thanks, I got off my presentation. So what I want you to pay attention to is UL versus ASTM, okay? UL is a pass-fail. So let's say you're going to go have heart surgery done. Do you want someone that passed, or do you want to be ranked and have the best doctor that can provide that surgery for you, okay? Realtor's exams, pass-fail. Bar exam, pass-fail. That's UL. ASTM takes that testing and it pushes it to ultimate failure, which that means is it ranks it. You can extrapolate the data out, and that's the best way I can put this in perspective. Is UL is I got 70.1% and passed. ASTM is I am rated the best doctor to do this surgery. And that's what I would want if I was going under the knife, right? ASTM versus UL. Okay, I'm going to skip past this. Recyclability, metal's recyclable. Cool pigments in paint. I'm sure some of you may have heard this. Cool pigments. All that means is someone that has a lot more background than I have in chemistry and knows what's going on, puts magic fairy dust into the paint that doesn't change the color, but causes it to reflect more infrared. That's all cool means. Doesn't change the color, doesn't do anything like that. It's just reflective pigments in the paint for higher reflectivity values, even in darker colors. And in interest of all this, I'm going to skip past some of this. Okay, PV. A metal roof solution can incorporate PV, no problem. There are companies out there that use a clamp type. I don't think I can say names on this presentation, but there are manufacturers that use a clamp type. These clamps can be used for PV. They can be used for snow retention. They can be used for signage. They can be used for securing catwalks, snow melt, anything except for fall protection. Secure fall protection to the structure itself, not to the panel system, because metal manufacturers don't test for the loads that are going to be incurred by a 200-pound gentleman falling off the roof with a tool belt when it pulls on that roof. Fall protection is attached to the structure. These set screws can be good for anything else. Multiple manufacturers out there. Here's what it looks like going down. We've got to catch up on time. So clamps go down, framing goes over, PV goes over the top, boom, no penetrations. Okay. Dissimilar metals. Everyone here knows that, right? Keep metals separate. All right, solar panels. Yes, questions and answers. We're at the next stop. We made it. Thank you, everyone.
Okay, take a breath, Jeff.
Right?
We're good. Okay, we've got a question here. How much can you bend a 24-gram standing seam, for example, to wrap it down the wall and become siding?
Okay, so I'm going to assume you mean how can you bend a 24 gauge panel to wrap down the wall?
Gauge.
Got it. Okay, so metals, the standing seams themselves can't be bent. If you're going to do a waterfall transition, which goes over a wall and down, I actually wrote an article for metal architecture that touches on that, and it's the whole area that I don't want to get into, but you have to cut the seams and fold the panel down the wall and then put kneecaps over the top. I can send you my article that I wrote 3 years ago that covers all of this, but you have to cut the standing seam legs in order for it to fold down the wall. It's a very modern thing to do, and a lot of architects and design professionals like to do it. It can be done, and I can walk you through how to do it. I'm going to touch base on that later in the presentation, but reach out to me for my article as well. I will answer this question in this section.
Next question. Do we need both WRB and an underlayment?
Okay, WRB can be interchanged for underlayment, and underlayment is what's typically used under a metal panel, and a WRB is a water-resistive barrier that can be used on a roof and or walls. If you're going to use underlayment on a roofing assembly, it should not be used on walls. WRBs on walls are typically Tyvek type 2s or type 3s, sometimes type 1s, with a different perm rating as compared to an underlayment on a roofing application. Most underlayment on a roofing application has a perm rating of 0.05 or less, oftentimes 0.03. It is vapor closed. It is meant to keep everything out. So wrap your walls with a WRB. 9 times out of 10, it's typically a type 2 or similar with a 0.1 perm rating in that area. But as far as underlayment goes, underlayment on a roof should be vapor closed unless you have an entire vented roof assembly, vented ridge, vented eave or soffit, if that makes sense.
Okay, let's do one more. This one's pretty specific. I have a 6-inch Tectum deck with plywood on the outer surface. Can I install rigid insulation over that than the 22 gauge standing seam roofing?
Tectum. That is a very rare deck to be used. It looks like shredded wheat, and it doesn't have good pull-out values whatsoever. There's a lot more nuance to this conversation. besides what you can and can't use, because you may have to do a pull-out test if you're going to fasten anything to this unless you're fastening through. So I would like to table this. I have all the information on it, but it's not a quick discussion.
Okay, let's get back to the presentation and we'll get into the questions again later.
Okay. Design and installation considerations for roofing. So if you can hear this, it's wind blowing. Wind is the essential factors in roof design. It's huge. The non-continuous attachment of metal roofs makes them particularly susceptible to wind uplift, which is defined as the upward force exerted by wind traveling across the roof, right? Poor design, faulty construction, or incorrect materials results in massive damage. I'm going to skip some of this. This is all building specific. When you specify a metal roof, you should be able to talk to the metal roofing manufacturer, and they should be able to provide manufacturer's calculations for wind uplift and attachment points for your roofing system based upon your building specifics. What I mean by that is your exposure category, your wind speed, your height, your slope. All these are site-specific calcs that need to be taken into consideration to pump out your ASC 7 calcs. Okay. Structural standing seam metal panels are also tested under ASTM E1595, which is uniform by static air pressure difference. A multitude of other ASTM tests that I typically would go into if we didn't lose 10 minutes of the presentation. Again, what I want you to look at here, keep in mind here, is ASTM is pushed till failure. UL is not. Okay. Factory mutual, I'm going to touch on this real quick. If you want to go FM, you should have an FM insured roofing system. If you do not have an FM insured roofing system, don't go FM because it adds a bunch of variables in there and things to adhere to that you otherwise wouldn't have to. Okay, so there is testing for ASTM E1680 air and 1646, which is water. With proper sealant placement, also exposed fastener panels can provide adequate air and water infiltration. Standing seams that require mechanical seaming in the field that also require panel-to-panel end laps will often be tested under ASTM E2140. This is a water infiltration test of the panel-to-panel end lap that has 6 inches of standing water over the lap condition for a period of 6 hours with no signs of leakage on a pressurized panel. So if you're worried about lapped panels having issues, don't. Evaluation reports, they're IATMO UES, ICC UES. These are independent third-party testing bodies that take the ASTM data and extrapolate it out, which is typically required from state approval agencies. I'm going to skip past this. Okay, let's get into some details. There are 3 ways to accommodate for thermal movement. The low end of the panel, your floating eave, standard 90% of your applications. The high end, which is the shed roof that folds over, right? Or both. Panels are typically pinned at the high end or upslope of the panel. This is your drag load. So to accommodate movement at the high end of the panel, the low end has to be pinned. Remember, these metal panels want to party, they want to dance, they want to expand, they want to contract. They float upslope or they float downslope. Okay, so pin at the bottom to float up, pin at the top to float down. Not brain science. The third method is you allow expansion and contraction at both the high end and the low end. This is typically done on long panel runs where there's a secured panel in the middle of the field and it floats uphill and then downhill. And I'll show you why this happens. But it's important to not pin at more than one location. And what I mean by this is typically you pin at the top and let it float down slope. Okay. If you have a mechanically seamed panel where the panel's rolled into the clip, that clip has plus or minus 1 inch of movement. Steel moves 1/8 of an inch over a 10-foot stick. Can move. I should say that. Can move. Aluminum is 1/4 of an inch. This is in sheet form, of course. So 1/8 of an inch of movement gives you essentially 80 foot for expansion and contraction of 1 inch. Those clips have 1 inch of movement, which limits you to an 80-foot run in one direction. If you have a long building or a long roof, you can fix it in the middle and run 75 or 80 foot up, 75, 80 foot down, and now you have a maximum of 150 to 160 with a fixed clip in the middle. Float it up, float it down. Okay. Panels are fixed at the high end of the ridge condition in 99, probably 95% of instances, and free movement is required at the panel's low end or the eave line. This is that detail. Correct and incorrect. I love photos like this. Okay, going back to the question where you wanted to fold it over the edge. This is what it does, okay? You cannot bend those seams. When you fold that, those seams don't stretch. It's like a record, right? The inside moves slower than the outside. The outside moves a longer distance. So you can't fold those seams. You have to cut them. When you cut them, you have to put a kneecap on. This is the kneecap. This covers that transition. This can be done. However, this creates a point of fixation. And when you create a point of fixity, you now have to float the panel up slope. So in this instance, you must use a floating ridge or floating high eave condition. If it's a shed roof, the top must be able to float. Point of fixity at the eave line, and then it goes down the wall. This is what kneecaps look like installed. So again, care must be taken in this detail because the thermal movement is going to occur, and this movement must be accommodated for. The eave transition, i.e. waterfall, i.e. roof to wall, requires a floating ridge because of this point of fixity. Do not use this in climates where there's snow. This is a picture of a failed kneecap in snow country because the freeze thaws burst it open. Okay, a floating ridge is required if the eave is fixed. This is what I was just speaking about. As you notice, right here, the drag fastener does penetrate. I didn't have a good detail to pull out years ago, but the drag fastener should not penetrate the substrate and are secured into the gauge for the panel for the support. There's a step in this ridge cap right here. You see this ridge cap as it wraps around this Z, and this ridge cap acts as a spring which allows this panel to move up and down like that. For longer roof runs, a fixed panel or lap is in the midpoint may be used. Fixing a panel mid-span requires both a floating ridge and floating eave. Again, fixed in the middle, floats up one direction, floats down the other. You get two panel lengths now. If you don't want to go with a on-site roll-formed solid length panel. This is done on long panel runs, 70-foot plus, or on barrel roofs. Expansion and contraction does make it difficult to allow for just one end, so it has to be allowed at both ends of the panel. The overlap between the hidden cleat and the turn under end of the panel at the eave may need to be increased to accommodate for the thermal movement. It's important that they're not pinned at more than one location. Stagger your panel laps. It's good form. This is called swedge marks. If you see those little ripples that look like this in those panels, and that's again because these panels cannot be nested, as I was describing earlier. Through fastened panels are nested. You can't put these inside when they're the same width. So you have to squish them, swedge them so they fit. Fixed clip detail. Here's a fixed clip photo. Say that this is pinned in the middle of your roof, right? Barrel roof that can go down to the right and down to the left, or a long panel run. But this is what a fixed clip looks like and what a floating clip looks like. Again, this is used in mechanically seamed panels where the clip is seamed into the roof, not with a batten, like a T-seam or a bolt seam. It's often used on these barrel roofs. I'm blasting through this now. Okay. Barrel roof, fixed in the middle, floats down both sides. So panel ends. So varying panel width and thermal movement needs to be considered when detailing full-length roof panels at the gable ends of a building. In most cases, installers will not be able to utilize the full panel width at these ends of the building. So this detail allows for the cutting of the panel to the necessary width and field bending the panel edge up 1.5 inches or 2 inches or 2 3/8, depending on your panel type, to protect against infiltration of wind-driven rain and particulate and so on. Once this panel has been turned up, the panel edge is inserted into a receiver trim, as you can see, and secured against wind uplift. This detail also will allow for the unrestricted thermal movement of said panel within that receiver trim. Drag loads. Take them into consideration. That's what we're going to talk about here. Snow and ice imparts a live load, the slope of the roof, length of the panels, the loads involved. Pay attention to your drag fasteners. I once did a job in Truckee that required, I want to say, 16 fasteners per panel for the drag load because the snow load was just so ridiculous. So cold climate design. Cold roof systems that keep the roof temperature near the same temperature as outside air may be the best for preventing ice dams formation when properly designed and ventilated. Generally speaking, in heavy snowfall areas, you want to design a steep roof pitch as possible to allow for snow runoff. Self-adhered underlayment should 100% be there. And if possible, valleys, gutters, roof elevation changes should be minimized or eliminated altogether in these areas. Penetration should be located as close to the ridge as possible to minimize snow accumulating on its way down. So this is the same with water. If you have a penetration at the bottom of a panel run, all the water from the top of the panel will run down, and you're having more water run, more snow run that collects towards the bottom of the panel versus the top. So moving penetrations to the top is always preferable. Snow retention devices can always be accommodated. But when you do accommodate the snow retention device, work with the manufacturer / engineer for the connection and quantity of the retention to the standing seam themselves. Again, that's with those clamp type manufacturers. They should be clamp or screw type. I touched on that. In certain instances, you're going to require a wide valley. And what I mean by that, again, is because if you look at the top of the panel, it only the panel run, way up towards that top, there's only 2 panels that hit that valley. As you move your way down, all the water from the other panels hit and it collects and it will roll back on itself, right? So a wide valley may be needed to accommodate all that movement from the water downslope. Pipe boots. This is my pet peeve. Don't attach a pipe boot to a metal panel and then fasten the pipe boot through the panel into the substrate. Okay. Pipe boots are like slinkies. The bottom stays, the top stays stationary and the bottom moves with that panel like this. That penetration's here, but the panel moves around it. That pipe boot should move with the panel. So you cut the hole large enough to go around the pipe penetration, but not through the panel to secure it. It has to move, right? So typical rule of thumb is if it's in the middle of a panel, you want 4 fingers of width on either side for water to run around. Cut the hole to the width of the penetration plus a little bit so it can move with that metal panel. Now, if you don't do it right, things like this happen. Hole, again, is large enough to provide adequate room for thermal movement and pipe vibration and so on, but not secured to the substrate. Now, if you have a pipe penetration that's in the middle of a panel run or larger than 1 panel width, you move up to this. This is the cut rib or home plate detail. This is the detail that allows you to do 2 panelets. 1 panel, 2 panels. 1 panel, 2 panels. On the left is no. On the right's good. Okay. Anything over 3 panels gets curved. 1 panel, 2 panels, 3 panels, a plus. Easy. You can mount anything you want on a curb. Skylights, a collection of pipe penetration, solar tubes, HVAC, ventilators, whatever you want. Use a curb. Okay. We made it, and everyone is still here after a reset of the computer. Good job, team.
Okay, let's do a couple more questions, Jeff, and then we'll let you go for the day.
Did I make it within the hour? What time is it? Oh, 2:60. We made it all around, team. Good job.
Yeah.
Okay, let's do some questions.
Quickly, when writing specs, Master Spec wants to know if the fluoropolymer Kynar coating is a 2-coat, 3-coat, FEV, or mica system. What's the difference?
This is correct. You're typically going to use a 2-coat fluoropolymer system. There's differences in the paint types. I can touch on that. What I'm going to say to that is if you have questions, shoot me that email and I can walk you through with a different paint system. It differs because there's prints and there's metallics and there's marine coating finishes, as I was talking about, where you can use that paint system over water. Standard is a 2-coat. A marine finish is going to be a 3-coat with a gloss even. And then you have metallics and your prints, like your wood prints and so on. So it really depends on what you're using. So whatever look you have in your head that you want to go for, reach out to me and go, Jeff, I want to use this wood print. Okay, well, here's your paint finish. Or I want this metallic fleck. Okay, here's your paint finish. So that's going to vary depending on what you choose and your design aesthetic.
Okay, let's do one more. What is the ASTM UL standard for cool magic fairy dust paint?
Okay, so I like that you use the magic fairy dust. Good job. It's going to depend on your roofing application. What I mean by that is here in California, we have something called Title 24, which is going to require a minimum SRI be used over 1,400 square feet or more of conditioned roof space if it's low slope. When what that means is anything under 2 and 12. So 2 and 12 plus, you're wide open. You can use matte black or whatever you want. If it's under 2 and 12, over 1,400 square feet of conditioned space, you're required to use a minimum SRI of, I believe, 82 off the top of my head. This varies from application to application, and it also varies on which approach you're using to achieve your rating. So my answer to this is it depends on building type, location, slope, etc.
Okay, thank you, Jeff, and thanks to everyone who joined us today. If you need to reach out with any additional questions, the presenter's contact information is currently up on the screen. Just a reminder before everyone leaves, if you would like to rewatch today's presentation or share it with a colleague, we'll be emailing the link to the recording to everyone who registered for the webinar within a week. As well, it may take up to 5 business days if you're requiring a certificate, so keep an eye out for your inbox. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey, as it helps us to continue to serve your needs in the future. On behalf of Metal Architecture and AEP SPAN, thank you again for joining us and enjoy the rest of your day.
Thank you, everyone, for attending, and feel free to email me with any questions or concerns.
Thanks again, Jeff.
Thank you.